If you have seen or played Fall Guys, you might know of a little game, run around on a hex grid, and the hexes fall away from under you, and eventually you'll fall down to a lower level if you cannot make it on top of a hex until you're out of the game, and the last one down wins. Well, now in 5.6, we can actually recreate that functionality very easily with PCG. And this is the effect. We run around and the tiles kind of shake a little bit behind us and then fall away. And if we jump down, they will do the same. It all remains as it was. We can continue going down and down and down. And if we just stand there, it also does not shake the camera. And then we're all the way to the bottom. But the main thing is this entire thing is one PCG graph that I can just take anywhere I want, place it. I can even, for whatever reason, rotate it. It is just a simple PCG graph that you have full control over. So let me show you how everything's set up. To get started, we're going to need to make sure we have a few plugins turned on. So go edit plugins, search for PCG, and you want to turn on the procedural conjuration framework, PCG. Also searched up instanced actors, and you make sure you have instanced actors turned on and the instanced actors interop for PCG also turned on. And when you have everything turned on, go ahead and restart your engine if needed. So what I'm going to do is I'm going to create the hex grid right in Unreal. So we can just use what we get in Unreal so we don't have to bring anything in by going to selection mode and changing that to modeling or hitting Shift 5. Then under the create section, we can go ahead and select cylinder. And then you can see if I just move my mouse around in the viewport, I go ahead and have the option of actually placing a cylinder. But we don't want a cylinder. What we want is to change some values. For me, I'm going to change the radius to 100, the height to 20, so it'll be a lot flatter now, and the sides to 6, so we get a hexagon. And once we're happy, we can just click, and we can get it inside of the world, and then hit accept. Once you do that, you will see it is in a folder called _generated with your name here, and you'll see there is our cylinder here. Now, I'm going to just go ahead and rename this to just SM_hexagon, and then I'll open it up. Here's our nice hexagon. There's a few things we want to change for this. Mainly, I want to give it collision. So I'm going to go under collision here. Instead of adding a simple box, capsule, or sphere, we want to do a auto convex collision. And here in the bottom right corner, we could specify all the settings we want. I'll just leave it on default and hit apply. And this is the collision that we get. So that is good enough for us. Because now we'll be able to actually go ahead and stand on it or use it for overlap or anything else. And if you want to make sure you did it correctly, just go ahead and test with it, and you'll see if your character is stepping on it, then the collisions is set up the way you want. I'll go ahead and move this to the PCG folder for convenience. And now we can go ahead and get started with the actual PCG graph, spawning the actual full hex grid with the multiple floors. So what I'm going to do is right click, go to PCG, grab us a PCG graph. I'm going to use an empty graph. I'm going to call this PCG Hex-A-Gone. And I'm going to drag it out into the world and just put it at origin. And then we'll also need a blueprint that holds it. So I'm going to right click, go to blueprint class, select actor, and this is going to be our BP_Hex-Gone. And I'll open up the blueprint, and we're going to need a few things in this blueprint. Starting with a simple box collision. All this is for is to house the size of our entire area. So that way we could say we only keep points within our bounds for certain things. So in our box extent in the detail panel, I'm going to set mine up to be 2000 by 2000 in X and Y. The Z can stay as is. That is completely fine. And then I will also add a spline, and I'll just move the spline to be under the root by dragging it onto root and hit attach. So it's separate from the box. And then what I want to do is come in here, zoom in, remove this point that's sticking out, then right click on the original one and go to spline generation panel. I want to generate a circle. Now the circle radius will be the same size that we put into the box extents. So that is going to be 2000. And you'll see the points here are extending all the way to the edges. We're going to change the number of points here to 6. So it'll be like a hexagon, and then we're good. So from here, we do need to scooch it over. So I'll deselect it and reselect the entire spline component so I can move it over. And as you might have guessed it, it's moving over exactly 2000 in Y to make sure it's right in the middle. Now, a few other things. We need to make sure that it is going to be a closed loop. And what I want to make sure is all the points are set to linear. So I'm going to right click on one of the points, select spline points, select all spline points, top option. I'm going to right click on the spline point type, linear. So you can see here now we have effectively created a hexagon inside of this box. Now, it is not required that you do this exactly. You could absolutely have any kind of shape. I think it'll just be a little bit of fun to have a hexagon that is made of hexagons. The last thing we need to do is add ourselves a PCG component here and plug in our PCG graph into the instance, and we should be good with our blueprint. So now what I'm going to do is take this blueprint hexagon, drag it out to the world, go ahead and open up the actual PCG graph and get started with that. In our case, we started with a spline, so we might as well get the spline information that we actually created. We'll grab ourselves a spline sampler, and here we need to configure a few things, starting with the dimension. Dimension is going to be on interior. The interior sample spacing and the interior border sample spacing will be set to 200. Because we set 100 for the radius of the hexagon, we know that the longest side is going to be 100 in radius, which means it's 200 in diameter. So that's why we're setting 200 to be our value. Obviously, if yours is different, set yours accordingly. But in general, all the values that I'll be providing will be based off of this size. So if yours is bigger or smaller, you will need to, of course, adjust for your setup. And now if I hit A, you will see here we have our shape. Now, it doesn't look like a great hexagon in this display, but we're seeing that it is working for what we need. And if we take a look now already, we can use a simple static mesh spawner with a simple mesh entry here with this hexagon. So you just take a look at what's going on in the actual world. And one thing you'll quickly see is, yes, we have the hexagons in, but they're not going to line up. Well, I mean, they do. They touch perfectly here, but we have a few issues with them needing to be in between and then scooched over accordingly. So effectively, every other row needs to be moved to the right, and then every row needs to be shrunk together to kind of fit next to each other. Otherwise, we'll have way too big of gaps in between things. So what we're going to do is we're going to find every point on even rows. Then we're going to move those to the right, and then we're going to see, based on the rows, how much every row needs to actually shrink together to make the correct sizing so we get our perfect grid the way we. So let's get started setting that up. I'll go ahead and detach the static mesh spawner for now. What we first want to know is how many rows we have and kind of their value, if they're in the positive or negative direction. So what we can do is take our spline sampler here and then use a subtract. Now the subtraction is going to be based off of the original actor. So I'm going to right click and search for get actor data. In the get actor data, we're going to change it to get single point, and that's all we need here. And then we plug that into the subtract. Now it is going to complain because we haven't set up the subtract yet. We don't want to subtract last from last. What we want to do is subtract point of position, but specifically .x in input source 1 and input source 2. This way, if we move the entire actor somewhere else, we'll still get the relative values instead of the absolute. Because obviously, if you move it way far in the x value, it's not going to be positive and negative values. It is just going to be positive or negative. But we don't want to overwrite its actual position x. So in the output target, we're going to change it to row, so we know which row. And if I go ahead and press A on the subtract node and then scroll to the right, you will see now here row minus 200, 200, 600, etc. You can now see it is getting the actual x position relative to our actor of all of these points. And because it is, again, a diameter of 200, we can go ahead and use a simple divide node and to divide it by 200. And now if we press A on the divide node, you can see here's a row. And if I click the row button, we can sort by it. So we can see -8 is the lowest, all the way up to +8. So we now know where every single point is in terms of a row. So that's great. Now we need to filter based on the rows because I want to filter out the odds and evens from each other. So from here, we can drag out and search for filter attribute. And we want to use filter attribute elements. Now, what is the filter going to be? Again, it is going to be whether it's odd or even. So from this divide, we'll drag out and search for modulo. We want the attribute math modulo, and the in B is 2.0. So if it divides evenly in 2, it'll have a return of 0. Otherwise, it will have a decimal point return telling you kind of the fraction that is left over from the division. And because it's odds and even, it's very simple. We can just do a simple compare here if it is equal to 0. So that means it is either odd or even, in this case, even. So that is going to go into our filter. Now we still need to filter out the actual specific things. So with the filter attribute element selected, we're going to use the target attribute to be point density. In our case, density is 1 for everything, which is great. And the filter can just say at last, because this is going to return a 1 or a 0 because it is a Boolean. So we just need to check if it is equal here. If the density is equal to the filter, aka it is equal to 1, then it is inside the filter. If we just drag out of inside filter and search for a debug, and now press A on it, you will see on our viewport here, we have selected every other one. And same thing, if I change to outside filter, it is again going to be every other one but one off. So we're now filtering out evens and odds. Great. Now, one of them needs to move. So in our outside filter, we'll just add a transform points here, and we'll move these up in positive Y 100 units, which is half of the size of the hexagon. Now, I'll need a separate transform points here, so let's go ahead and add that in. And I'll plug both of them into the transform points. And I'll actually grab the static mesh spawner and plug it into this transform point so we can see kind of what it looks like at this point. As you'll see, we have the hexagon in. Well, that looks pretty good. It's not quite what I'd like because it's a little bit too far over in these directions. I want a little bit less of a boundary between these. So what we're going to do is scale them up. So in this transform points that we just added, I'm going to turn off uniform scale and I'm going to scale them by 1.1 in X and Y for both minimum and maximum. I don't want to scale it in height. We don't need that. So that results in us having far better spacing here. But the problem is the spacing here is too big. And that's what I was saying. We'll need to actually move these over and kind of scrunch them in a bit. So how do we do that? Turn off the static mesh spawner one more time. I'll go ahead and merge all these points together because right now they're two separate groups because we filtered them out inside and outside. So we'll put them back together. And based on the values that I have, what I have found is if I grab ourselves a multiply node and I multiply by -20, but the value I'm actually multiplying isn't last, it is going to be our row. Now, a row, as you recall, is what we actually added over here. On this subtract, we have created the row, and here we use the row. Now, here we left it on last because it automatically does the row because it was the one right before it. We can absolutely just type in row in here to be safe in case we put something in between these two nodes. So now if I press A on this multiply and we take a look at the row, you'll see we have our rows multiplied by 20 for every point. Fantastic. So now we need to offset them in positive X. So from the merge points, I'll use an add attribute, a simple add operation, and it's going to take this multiply into B. And on the add node, we're going to be modifying the point position, but specifically .x in the X direction with row in input source 2. So now if you take a look with a slight offset, these look a lot nicer and a lot more close up where I'd like them. You can absolutely play around with these values for yourself, but this looks pretty good to me. The only thing left to do is actually just copy it up. And thankfully, at this point in time, we do have a simple node for that, which is a simple duplicate point node. So we'll grab that in between the static mesh spawner and the add node. And on it, let's duplicate it up 3 times. The direction is going to be upwards. And if we open up the point transform, we can tell each point to be 500 units up in the air. So if we take a look now, we see there's our hex grid going up. Unfortunately, because the spline is the way it is not a perfect setup with this. So what you'll probably need to do is grab the points and just slightly finesse them a little bit. And let's say I am happy with this. Now, because I'm using this basic actual shape, I would like it to have a little bit of color. So I'll actually open up the SM hexagon one more time, and I'm going to change the material from this world grid material to a basic material. I'll go ahead and just pick this basic asset 1. If you do not see this, click the cogwheel and make sure you have engine and plugin content enabled. And then also like this simple basic orange. And as you'll see, we now have the hexagons all orange, so it's just a little bit nicer. Now, I'm also going to just change the angle of the sun here so it doesn't quite cause shadows. If we take our player start and just move it all the way up into the air, we can actually go ahead and just hit play. We'll fall and we'll go right through everything. Because even though we put collisions on this, the actual ones spawned by PCG by default don't have collisions, but that's okay because we're not going to be using static mesh spawners for this. We're going to be using the new 5.6 Instanced Actors interop that we enabled earlier. So things are going to be instant static meshes overall, but when the player is in range, it is going to turn into a blueprint. So that way we can actually put logic on the ones that are just nearby. So let's go ahead and set it up. And actually what I'm going to do is take this entire thing and I'm going to raise it up. So that way, when I go ahead and land, I'll end up going through everything and then end up below it in the end. For yourself, if you're going to be using this, you could put a big volume on the bottom and just say, hey, when you go into that volume, you die, game over, etc. But because we're going to be using instant actors, let's go and create our setup. We're going to right click and grab ourselves a blueprint class of a type actor. It is going to be a BP_hexagon platform, and I'll open it up. For the components, I'm going to add a static mesh component And because I have the hexagon already selected, it already shows up here. And if I select it, it goes ahead and populates it in with the name. So already we can start using this. Back in our PCG graph, instead of a static mesh spawner, I'm going to change that for a spawn instanced actors. That's going to complain because we have an error from nothing being plugged into it. The instanced actor is going to be our BP Hex-A-Gone platform here. So go ahead and select it, and it's going to throw us a lot of warnings. That's because we haven't actually set up instanced actors yet at the current moment. So we'll go ahead and set it up for this. That way, all these warnings will go away. To do that is very simple. All we do is right click, go to miscellaneous, and go to data registry. We just want to select the only option here, data registry, and select, and I'll call it dr_Hex-A-Gone. And then go ahead and open it up. Now, I'm not going to go super in depth on how this is all set up and everything about instant actors, how they work. I have a full dedicated video that's already been released that you can check out. I'll also make sure to link it at the end of the video if you're interested in it. For now, though, I will still show you absolutely everything you need to do to get it working for this. We'll start with this item struct because that becomes a little bit easier this way. If we search for instanced actor, you'll see a bunch of instanced actor things. And the one we want is instanced actors class settings. The registry type is also this. And the reason I selected this first is so that way we can go ahead and have a reference for actually typing out this without any typos. Type it in exactly the same instanced actors class settings. Then we need a data source. So I'll go ahead and press 1. It'll give us an index here of a type to choose. I'll choose data table because that is the one that I'm most familiar with. And then we can open it up and select a source table. Now we don't have one, so we'll go ahead and just click on data table to create one. I'll put it in the PCG folder called dt_Hex-A-Gone. And then it wants a row structure, and as you might have guessed, it is the same here as well, instanced actors class settings. And hit OK. And then you'll see it is populated in, and we can open it. Now by default, yours will look something like this, with the row editor on the bottom and the data table on the top left. For convenience for myself, though, I will just make it another tab. The main thing we want, though, is to add a new row. Now, what is going to go into this row? Well, it's actually this right here, BP_Hexagone platform _C. That used to be the row name. So I'm going to rename this row to be exactly that, BP_Hexagone platform _C. And then _C is important. So make sure you still have the _C. And now with it selected, if we go to the row editor, we have a few options. So that's great. I'm not going to change anything as of yet. I'll explain what we're going to be doing in a bit. First, though, we need to finish the settings by going to Edit Project Settings and then go to Data Registry under Game here on the left. And you want to add a new directory to scan. So add a new directory, press the 3 dots, and we're going to specify PCG or whatever folder you've actually put the file in, the data registry stuff. You can, of course, make a separate folder just to hold all the data registry stuff, but wherever it is, make sure you have selected it here. In my case, it is the PCG folder, so I'll go ahead and select it. At this point, I can close out of here. And if I go back to the PCG graph and click Force Region, you should have 0 pop-ups and 0 warnings. If you find yourself you have an error, it might be like me, or I accidentally mistyped this registry type. So if I put in the correct value in here and then go back to the PCG graph and hit Force Region, now I do not have any pop-ups. So again, make sure it is actually all typed incorrectly. If it is, you should have no warnings when you hit Force Region. So now what do we get? Well, if we hit play, we'll go ahead and drop and we'll land. Now, why do we land? Because it is landing on a blueprint and the blueprint has collision. So now we can just run around here as normal and you can't even tell that certain ones are actually no longer a blueprint somewhere. But of course, we want to customize things. So going back to our data table row editor, we can change a few things. The first thing I'm going to change is the max actor distance. 1,000 is fine, but we can get away with 750 as our range. So instances within 750 radius of us will become the blueprint. Everything else will stay in the static mesh. The other very important one is this, eject on actor moved. If I go ahead and enable that and turn on the actor ejection movement threshold, we can customize how far does the actual instance need to move before it is ejected from its hive mind, if you will, and becomes its own separate blueprint. Well, in our case, I want it to basically happen on any movement. So I'm going to make this a very small number. So if I move this actor at all, it is going to go ahead and just stop being an instant static mesh component and start being a pure blueprint actor. If it doesn't move, then we're fine. It doesn't need to then become a blueprint actor. Instead, it will retain its instant static mesh and we'll be good. That's honestly all we need to do here. We can now go back to the BP Hexagone platform and customize this. Now I want to add an overlap section. So if we walk over it, then we start the effect of, hey, we've landed. Problem is under components, If I search for collision, we only have box, capsule, and sphere, and none of them are really good for the shape. I'm instead going to use this hexagon. I'm going to duplicate it, suffix this with underscore overlap, because we're going to be overlapping this one. And this one's going to go up above. Now, to make sure that I know which one it is visually, just by looking at it, I'll just change the basic material over here on it. It's going to be green. And if I search for collision in the detail panel, we want to customize this one. Instead of block all dynamic, I'm going to set it to custom. I'm going to tell it to ignore everything except pawn that we're going to set to overlap, because we only care if a player is overlapping. We're also going to search for hidden, and I want to turn on hidden in game to be true. So that way we don't actually see this hexagon in the world. And now if we right click on this overlap hexagon, we can add an event on component begin overlap. And we can set up something relatively basic here. From other actor, I'm going to drag out and search for get instigator, and we want the actor variables one. And from here, I can drag out and search for is player controlled. So that way only a player controlled actor can actually do something with it. So there we go. If it is true, we'll for now just do a print string so you can see what's going on. If I now go ahead and hit play, you'll see hello. And as I run around, you'll see hello is printed in the top left corner. And as you can tell, we do not see any of the green hexagons that are actually on top of here. So now we need to introduce them actually getting destroyed. But I don't want to just destroy them. I want it to shake a little so you can see visually that it's about to actually go bye-bye and then go away. So what we're going to do is just a little bit below, I'm going to right click and search for custom event. And we're going to call this just shake and destroy. And from this branch, we're going to, instead of this print string, call shake and destroy. So if it is a player that is on top of it, it will go ahead and shake and then destroy. Now, I don't want it to start shaking immediately, so I'll just add a simple maybe half a second of delay, so it doesn't immediately start shaking when you just touch it. For the shake effect, though, I'm going to do a set timer by event. The time is going to be 0.05, so it's going to be about 20 times a second. It's going to loop, and there's no reason for it to do more than once a frame, so we'll just turn on max once per frame as well. All we need to do is drag out of the event and search for custom event, and I'll just call this shake. And all shake is going to do is take our SM hexagon here, set relative rotation, because the only thing we want to modify, but we want to do a random values here. So I'm going to right click on the new rotation and split it, and then I'm going to right click and search for random float in range, and I'm going to go from -2 to +2 in X, and then I'll go ahead and duplicate this and do the same thing in Y and the same thing in Z. So it goes ahead and picks a random value for each one. You can also customize this to shake more in a certain axis if you'd like. Now, we want to actually be able to destroy that piece, so we need to move it. As you recall, we set it to be a very small movement is needed. So from here, I drag out and just search for set actor location. Now, you want to do the regular actor location. You do not want to do the relative, because we want to move the entire actor. When the entire actor moves, it can be separated from the rest of the cluster. And the new location will be its current location, so get actor location. The regular target is actor. And then we just want to do a subtract. And I'll subtract something relatively small, like 0.01. With it shaking, you won't even notice it. So that's going to become its new location. And then how long do we want it to shake? Let's go ahead and delay it for half a second. So I'll do half a second of shaking. And then after which I want to destroy the actor. So let's see what happens. If I go ahead and play and then I start running, you could see the platform's already dropping. It seems like everything is working fine, but here's the thing. If I stop moving, oh boy, things get very violent as it rotates, and my camera, because it is attached to the player, and the player is rotating, it becomes not very pleasant. Ideally, what I'd like is the platform to shake, but the player just stands still. So that's more of a visual shake. Now, there's two ways of doing that. One is to have it done in a material sense. You can apply world position offset to make it shake. Another option is what I'm going to be showing you here, which is having another invisible hexagon that is for the collision separate from the one that you're seeing. And what does that mean? Well, I'm going to take our hexagon, I'm going to duplicate it, and this is going to be your hexagon underscore collision. Now this hexagon underscore collision, I'm going to keep it as is. But on this regular SM hexagon, the one we've been using so far for everything, I'm going to search in the detail panel for collision. And instead of block all dynamic, I'm going to say no collision. It is just a visual thing. Now, because we did duplicate the hexagon, we still need to change the actual visibility on the hexagon collision one. So search for hidden to get hidden in game and turn on hidden in game to be true. And now if we take a look, if we play, you could see it is now disappearing as before, and if I stand still, it is shaking, but it is not affecting the camera, which is kind of the important thing for me. Shake, shake, shake. And there we go. It is now disappearing as I run across. And the delay that it is disappearing behind me at can be controlled by the delays we've put in. But now we have a full Hexagone style game created thanks to PCG and Instanced Actors that are now in 5.6 and all work together so well. Instanced Actors are so powerful and they're allowing us to have so many awesome gameplay mechanics that are just going to be so much more efficient by just having them activate within a range of the player. And I love it. Now, as always, I'm going to have the project files available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. If you'd like to join the community, the link to the Discord will be down below as always. As I mentioned before, if you're really interested in Instant Actors and you haven't seen it yet, I highly recommend checking out this video right here and getting really familiar with Instant Actors because I think it's one of the biggest things that's come to PCG.